Hello, and welcome to a little video about solving systems through substitution. But before we do that, let's talk about the types of solutions we can get. We kind of explored it yesterday when we were graphing, but let's take a peek at both graphically and algebraically. All right, types of solutions. Graphically, let's say we have a graph like this. When we graph both of our lines, they'll cross at some point. Algebraically, if they're both y equals mx plus b, the m's and b's are all different. Well, actually, the b's don't have to be different. The m's have to be different. The m's are all different. Okay, so all the slopes are different if they're in y equals. And if we solve them, you get an actual answer like x comma y. So these will be solvable. And again, if they are in y equals form, the slopes are different. M's, which are slopes. Ooh, let's put that in. Let's write slopes instead. Slopes. Perfect. Okay. No solution. Now this happens when we have a graph, and when we graph our lines, they end up being parallel. Parallel lines never meet. When we have these two equations in y equals mx plus b form, m's, or slopes, let's be better about this, Gumin, slopes are the same. So these m's, these slopes are going to be the same. Here your slopes are going to be different. Lastly, if we have infinitely many solutions, this is a weird one. So let's say we graph the first one, let's say it's pink, and then we graph the green one ends up right on top of the pink one, so it looks like one line. When they're both in y equals mx plus b form, slope and y-intercept, so m and b, are the same. So both m's and b's. So essentially, it's two of the same equation. Now, we don't always know when that happens until we write them as y equals. Now, for no solution, when we solve this, we get a false statement. Remember, like 8 equals 7. It doesn't. For infinitely many, we get a true statement, like 7 equals 7 at the end. Okay, now let's go to solving, keeping these in mind. All right, so we can have one solution, a false answer for no solutions, and a true answer for infinitely many. All right. The first method that I'm going to show you is called substitutions. Substitution is when we replace an x or a y that's already there. So let's start. I know I have some steps here, but you got me telling you how we're going to do it. And I think I also am going to give you a sheet of paper with the steps on them. So let's begin. The first thing we got to do here is determine which variable we are going to substitute. The way I do that is I see where does a y equals or x equals already exist? Right here. Well, that means I can take y and substitute it into that second equation. So instead of 6x minus 5y, I'm going to make this pen a little thinner. I'm not enjoying this. All right. 6x minus 5y equals negative 19. I'm going to take y and substitute negative 1 into it. And now we have a nice little two-step equation to solve. Let's get to it. Whoops. 6x stays. Negative 5 times negative 1 is positive 5. And it still equals negative 19. Next, let's subtract 5 from both sides. So now we have that 6x equals negative 24. And then divide both sides by 6 to get that x equals, whoa, not negative 8, holy cannoli, negative 4. Fantastic. So we've got x. And we've got y. Oh, that's it. This was a quick one. We do have to write our answer. -4, -1. Okay, let's try one that's probably, oh, let's take one more step. Let's try this one. Do you see either a y equals or an x equals? I see a y equals. Let's plug it in. We got 2x plus y equals 16, and I'm going to replace y. So I have 2x plus 2x. Ah, how nice. 2x plus 2x is 4x. And then the last step I gotta take here is just divide both sides by 4. X equals 4. Unlike the previous problem, we don't have that y equals a number. We have the y equals 2x. So what we're gonna have to do here is plug x in. So instead of y equals 2x, I'm gonna have y equals 2 times 4. So y equals 8. Okay. Our solution is 4, 8. Let's try another one. Ooh, this one has a little bit more to it. It's juicier. I have an x equals here, which means I'm going to be replacing x. Okay. So instead of 3x plus 4y, I'm going to have 3 times 16 minus 4y plus 4y equals 8. So I took x and I replaced it. All right, this requires a couple more steps, but that's okay. Let's distribute. Okay. 3 times 16 is the first thing we need to do. 3 times 16 is going to give us 48. 3 times -4y is -12y, and everything else stays the same. Let's combine these like terms, because they're both y's. -12 plus 4 is -8, so we have 48 minus 8y equals 8. We're going to have to subtract 48 from both sides because it was positive, and we undo it with minus. So we get that 8y equals -40. And we finish this by dividing both sides by -8, because -8y is -8 times y. Y equals 5. All right. We got y. Let's find x by plugging it into that first equation. X equals 16, and instead of 4y, I'm going to have 4 times 5. Okay, 4 times 5 is 20. 16 minus 20 is -4. There's our answer, -4, 5. Ooh, okay, this one has a y equals. Let's do it. I'm going to take this bottom equation and plop it into the top one. Substitute it in. So we get 5x plus 2, parentheses, -x minus 3 equals 9. All right, let's distribute. 5x stays 5x. 2 times -x is -2x. 2 times -3 is -6. Still equals 9. Let's combine the x's. 5x's minus 2x's is 3x's. Everything else stays the same. Let's add 6 to both sides. 3x equals 15. And then divide by 3. X equals 5. Great. Now that we have x, let's find y by plugging it into this equation. Instead of y equals -x minus 3, I'm going to have y equals -5 minus 3. -5 minus 3 is -8. 5, -8 is our answer. And if you're wondering, Gumin, do I really have to write the coordinates even though I have an x equals and a y equals? Yeah, you do. The problem is not complete until you do that. All right, let's try 2 more. Ooh, these are both y equalses. Now before we start this, can you tell me, does y equal y? Yeah, it does. So let's set the equations equal to each other. So I'm going to do x plus 4 equals negative x plus 8. Honestly, these I prefer graphing, but I want to show you how to do it algebraically. All right, I like to move my x's to the left, so I'm going to move x by adding it, which means I got 2x plus 4 equals 8. If I move my x's to the left, I gotta move my regular numbers to the right, and I'm doing that by subtracting 4 to undo plus 4. So I got 2x equals 4. And of course, we get to finish by dividing by 2. I ran out of room. X equals 2. Cool. Okay, well, now that we have x equals 2, it really doesn't matter which one I plug it into. I feel like doing the top one. So instead of, let's choose a different color here. Let's do green. Instead of y equals x plus 4, I'm going to write that y equals 2 plus 4. So y equals 6, and of course, I got to write 2 comma 6. Beautiful. Last one. Similar idea. See how these are both x equals is? Well, that means I can set them equal to each other. Just like I did in this one, x equals x. So, we have that negative y plus 4 equals 2y minus 8. All right, let's solve for y. Again, I'm going to move my y's to the left, and I'm going to do that by subtracting 2y from both sides. So now I got negative 3y plus 4 equals negative 8. Let's move 4 to the other side by subtracting since it was being added. So now we got that negative 3y equals negative 12. And I wrote too big, but that's okay, ran out of room again. I divide both sides by negative 3, and I get that y equals 4. Well, now that we have that y equals 4, we can use either equation to find x. Since they're both x equals, the top one looks easier to use, honestly. It really doesn't matter, though. Instead of x equals negative y plus 4, I have x equals negative 4 plus 4. Negative 4 plus 4 is 0. So our answer is 0, 4. Okay. If you have any questions, please make sure to ask me or whoever else is helping you with math. Otherwise, have a wonderful rest of whatever day it is for you. Bye!